अस्सलाम वालेकुम students, hope you are all good. आप सब अच्छे से होंगे. Today we will discuss smooth muscle contraction. We have already discussed how contraction occurs in the skeletal muscle. We know that troponin C, it binds with calcium, and this binding triggers the muscle contraction in the skeletal muscle. We know that there is an interaction between the myosin head and the actin protein, and this interaction, it leads to the sliding of the secondary myofilaments, that is actin, over the primary myofilaments, that is myosin. We have already discussed that in the skeletal muscle. But the mechanism which operates in the smooth muscle contraction, it is a bit different the way we have seen it in the skeletal muscle. थोड़ा सा डिफरेंस यहाँ पे आपको लगेगा. स्मूथ मसल कॉन्ट्रैक्शन कैसे होता है यहाँ पे कॉन्ट्रैक्शन, मैं आपको इसका बेसिक समझाऊंगा, इसका मैकेनिज्म मैं आपको यहाँ पे बताऊंगा. हाउ कॉन्ट्रैक्शन take place in the smooth muscle. Let us see. In the smooth muscle, there is, you already know that there is a myosin protein is there, a primary myofilament, and we already know that myosin consists of light chains and there are heavy chains. Myosin light chain, I'm talking right now about the myosin light chain. Myosin light chain itself, it is intrinsic in the myosin protein. This myosin light chain, it inhibits, myosin light chain inhibits binding of myosin light chain itself inhibits binding of myosin head with actin. So here the regulation is intrinsic in the myosin protein itself. So myosin light chain, it inhibits binding of myosin head with the actin. Now this inhibition, it needs to be abolished. इसको खत्म करना है. So some processing must be done with the myosin light chain. And what is that? वो क्या चीज़ है जिसकी वजह से then it will allow the binding of the myosin head with the actin. That is phosphorylation. That is phosphorylation. A phosphate group is to be added to the myosin. We know that in the life sciences, there are different means of activation, there are different means of inactivations. One of the means of activation and inactivation is the phosphorylation and the dephosphorylation. तो यहाँ पे अगर हम इसको phosphate add करते हैं, phosphate group add करते हैं, it becomes activated myosin light chain. So which is a phosphate donor here? Of course we know it is ATP. So ATP will give the phosphate here. One phosphate will go with the myosin light chain. So what will come out? ADP will come out. But here is very interesting thing. Here we require an enzyme. Here हमें यहाँ पे एक enzyme की ज़रूरत होती है. We require an enzyme. This will be another aspect. ये एक aspect होगा इसको समझने का, और ये दूसरा एस्पेक्ट है. पहले मैं ये कंप्लीट करता हूँ, फिर मैं इस एंजाइम के बारे में आपसे बात करता हूँ. सो वन इज दिस एंजाइम, इट इज टेकिंग फॉस्फेट फ्रॉम द एटीपी एंड इज एडिंग द सेम टू द मायोसिन लाइट चेन. सो आई शुड राइट, हम यहाँ पे लिखेंगे फॉस्फोराइलेटेड मायोसिन लाइट चेन. Phosphorylated myosin light chain. Now this is active. Phosphorylated myosin light chain. Now once it becomes activated, it will allow the binding of, it will allow the binding of what? Myosin head with F-actin. You know what F-actin I mean. With F-actin. Once this binding occurs, what will happen? Then the sliding will occur, and you already know what is that called. That is what is contraction. उसी को हम contraction बोलते हैं. Actually, myosin light chain, it inhibits binding of myosin head with the actin. Now once it's phosphorylated, then it allows the binding of the myosin head with the F-actin. And once the binding occurs, binding is accompanied by the sliding, and that is what is called as contraction. Actually, this phosphorylation, it activates ATPase enzyme which is present in the myosin head. You must be knowing this. आपको पता होगा बेटा, जो myosin head होता है, myosin head has got ATPase activity, because this sliding of secondary myofilament, sliding of actin over the myosin, secondary myofilament का slide होना over the primary myofilament, it requires what? ATP. It requires energy, and that energy is derived from the ATP. And this ATP, it is broken by ATPase enzyme, and this ATPase activity lies with the myosin head. So actually this phosphorylation, it is activating that enzyme. So once that enzyme is active, it will derive the energy from the ATP, and that will lead to the contraction of the muscle. Now listen, now once the contraction is over, it must get back to its original state, that is inactive mode, that is relaxation mode. So we must get the phosphate out. तो यहाँ पे phosphate बाहर निकलना चाहिए, and this phosphate, it is removed by an enzyme, phosphatase enzyme. Phosphatase enzyme is there, and this phosphatase enzyme, it will remove the phosphate back, वापस निकालेगा कहाँ से? Myosin light chain से. Once the phosphate is out, again it will come into this inactive state. It will not allow the binding of myosin head with the actin. So in short, myosin light chain, once it is phosphorylated and the phosphate is given, it's the ATP is a phosphate donor here. Once it becomes phosphorylated myosin light chain, then this phosphorylated myosin light chain, it will allow the binding of the myosin head with the effectin. And once the binding occurs, then there is a sliding, and that is called as contraction. And now once the contraction is done, then this phosphate is removed again by an enzyme called phosphatase. This is the core concept. This is the core concept of the smooth muscle contraction. Now, what is an enzyme here which is working here? यहाँ पे जो enzyme है, ये enzyme कौन है यहाँ पे? This enzyme is actually, it is myosin light chain kinase. I will write the name of the enzyme here. The enzyme is myosin light chain kinase. This is an enzyme, myosin light chain kinase. And this enzyme, myosin light chain kinase, MLCK, I can write it MLCK, myosin light chain kinase. This MLCK, myosin light chain kinase, myosin light chain kinase, it is initially inactive. This enzyme is initially what? Inactive. And now its activation into its active form, it requires two things. It requires two things, and what are those two factors which will activate myosin light chain kinase into its active form, so that now it will perform its job of what? Phosphorylation. Because kinases are those enzymes which are doing phosphorylation, which are adding phosphate, right? So for myosin light chain kinase activation, it requires two important factors. दो चीजें चाहिए यहाँ पे activation के लिए. Number one is calcium, and number second is a protein that's present in the muscle cell, that's called as calmodulin protein. So calcium first binds with the calmodulin, it becomes calmodulin, and this calmodulin, it activates myosin light chain kinase in its active form, myosin light chain kinase active. And now once it becomes active, then it phosphorylates myosin light chain. Then phosphorylated myosin light chain, once it's active, it allows binding of myosin head with the effectin. And once the binding occurs, that binding will lead to the contraction. And that is basically the sliding of the secondary myofilaments on the primary myofilaments. That is, the actin will slide on the myosin. But this sliding requires basically the interaction, the binding between the myosin head and the effectin. And once the contraction is over, the muscle gets back to its original state. And how it is done? Phosphate is to be removed, and which is going to remove the phosphate again from this? It is phosphatase enzyme. So this is how smooth muscle contraction, it occurs in the how it occurs in the smooth muscle. Hope your concepts are clear with the contraction of the smooth muscle. What's the core concept here I have discussed. Questions are being asked regularly on in Neet and in other competitive exams. I hope it's clear. So see you in the next topic with some new concept. Till then, Allah Hafiz.